Today we want to start to look at complex 2 or complex numbers 2. Saka complex numbers 2 builds directly from complex numbers 1. In complex numbers 1 takadzidza pamusoro pema imaginary numbers, where we saw that the square root of -1 is equal to I, and also I squared is equal to -1. Then we went on to discuss the structure of a complex number, where if we take a complex number to be set, it will be equal to a real number plus an imaginary number. Set is equal to x plus yi. Used that information to do the addition and subtraction of complex numbers, which is basically the same way we did with algebra. Went to the multiplication of complex numbers, the same as with algebra. The only difference comes with the division of complex numbers. Partial multiplier both numerator and denominator by the conjugate of the denominator. Kuitira kuti tiite remove a complex denominator. From there we went on to draw the argand diagram. We found the magnitude of a complex number. Tatazoenda kuno calculate the argument of a complex number using the argand diagram. Saka pa complex 2 we are going to start from forms of complex number presentation. That is going to be our first topic. Forms of complex number presentation. What is it with complex number presentation? Zvatikuda kuona. Saka, when we talk about the presentation of complex numbers, we start from what we know. So when we are learning something, always start from what we know. We have what we refer to as a standard form. Kana chiti standard form, this is the most widely used form in complex analysis. What is the standard form? The complex number set is equal to x plus yi, where we know that x is the real number, yi ndio imaginary number, set iri complex number. So this is called the standard form, the most used form. From there we are going to go to what we refer to as the polar form. Kana chiti polar form, what are we referring to? Tribute complex number set inenge iri equal to r, then we put a bracket, dot cos theta plus I sine theta. This is what we refer to as the polar form. And then we also have an exponential form. So what do we mean by exponential form? Complex set is equal to re to the I theta, like that. That's the exponential form. Saka, what is new here? The polar form and exponential forms. Polar and exponential forms are used to simplify the multiplication and division of complex numbers. We can write that as a point. Go to the polar form and exponential form is used to simplify what does it simplify? The multiplication and division of complex numbers. That is what it does. Okay, so the multiplication and division of complex numbers in polar and exponential form. Let us look at that. Saka kana tiri ku polar form, what is going to be happening? Saka tati polar form, it's written like this. Set 1, and which is the first complex number, tikatiri equal to R1, it's cos theta plus I sine theta. Tikati set 2 inenge R2 cos, not theta now, but we can say cos alpha, cannot cos beta. So ngatiti cos alpha plus I sine alpha, like that. Saka when we are multiplying these two complex numbers, set 1 times set 2, inenge chibuda yakaita say. Saka firstly, we are going to be multiplying R1 and times R2, like that. Then we put a bracket. Then we are going to be more like combining my cos power ega, so it becomes cos of theta plus alpha, and then plus we do the same for my sine, I sine of theta plus alpha. This is how we do the multiplication, and you can see there is a simplicity to it. Are there any questions on the multiplication? Okay. What about division? Set 1 dividing set 2. This would then be equal to, it's R1 over R2, like that. Then chakuchichinja panapa, takuchiti cos of theta minus alpha instead of plus, and it. Then panapa plus inodzoka, tovatati I sine of theta minus alpha, like this. Saka papari apply a principle in mathematics inonzi isomorphism, inongoreva kuti multiplication inofambidzana ne addition, division inofambidzana ne subtraction. That is what we are seeing here. So this is multiplying, where when we are multiplying, tirikuona kuti these two angles theta and alpha are going to be adding. When we are dividing, tirikuona kuti the two angles are going to be subtracting, but plus e irikuramba yakadi yakadaro. Saka that is it with the polar form, kana chitarisa simplification of multiplication and division. Let us now look at the exponential form. Exponential form, let's say set 1 is equal to R1 e to the I theta, then set 2 is equal to R2 e to the I alpha, like that. When we are multiplying set 1 times set 2, this is going to be equal to, it's R1 dot R2 e to the what? To the I theta, and saka panapa manyura tunoita nde aya, we are going to be secluding I. Saka it's R1 dot R2 e to the I, then in brackets toti theta plus alpha, like that. Then in like manner, set 1 over set 2 inenge equal to R1 over R2 e to the I, now yakuti, because it's division, theta subtracting alpha says. Zirikubatika. Okay. So what we have to take note of pano is this. When multiplying set 1 and set 2, we add the angles and multiply the moduli. When dividing set 1 and set 2, we subtract the angles and divide the moduli. Such rules the moduli chi is this part ma-ri. And saka zvandaverenga izvi, it's just a reiteration of this. So when we are multiplying the two vectors, we are going to multiply the moduli and add the angles, ma-angles chi theta na alpha. When we are dividing the complex numbers, we divide the moduli and subtract the angles theta minus alpha. Any questions?